Good. Okay, so as advertised, I'm Chris Wiggins, and I split my time between Columbia and the New York Times. I hope to tell you a little bit about how I got that way, and so that might be useful if you're thinking about data science and how to start a data science team. Maybe I can illustrate why it's useful to partner with academics. For example, you've got some good universities here. And if you're looking for data science jobs, I'll talk a little bit about how we think about data science in our team. Let's see which button makes it happen. It's happening. So first I'm going to tell you a little bit about how we think about data science at the New York Times. I am an academic, which means that I think words have meaning, and I think it's fun to look at the original definitions of words like data science, machine learning, AI, etc. Data science, for example, let's take a founding document from 2009 when people first started talking about the job title data scientist. This is a document from Jeff Hammerbacher. Just so I know my audience, how many people here know Jeff Hammerbacher? Nobody's heard of, oh, thank you. One person's heard of Jeff Hammerbacher, too. A couple people cheating. Jeff is well known for starting the data effort at Facebook because he went to college with Mark Zuckerberg. After going to finance for a year, he was deeply bored, called up his friend Mark and said, "Mark, what do you got?" And Mark said, "We got data." So Jeff went to Facebook and created a team with people called data scientists. Why did he call them data scientists? Well, he said, we felt like traditional job titles, business analyst, statistician, wasn't really cutting it because of the diversity of the things you might be doing. You might be building a product in Hadoop, doing regression, doing an A/B testing, and communicating the results of our analyses to other members of the organization in a clear and concise fashion. It's fun to look back at this document a decade later and see what things have changed and what things have stayed the same. For example, we're not really doing so much with the R these days in the data science group at the New York Times. We're doing everything in Python. Hadoop, well, a distributed MapReduce is happening, but it's in the back end. We don't really need to Hadoop anymore. When I showed up, if you wanted to get your hands on data, you needed to write Java MapReduce jobs hitting buckets of unstructured JSON and S3. It was bad times. Now it's all BigQuery's problem. So we're speaking BigQuery language, and that's how we do our data science as well as our data analytics. So the R has become TensorFlow, and the Hadoop has become GCP. So distributed MapReduce is somebody else's problem. Here's another ancient document to define data science. How many people have seen this ancient document? A bunch of people. OK, so this was from when Drew Conway was merely a graduate student, and he and I and other people were putting together a Strata conference, and he said, what even is this data science thing? It appears to be the craft of taking machine learning and putting it to work to understand some problem with some substantive domain. So people use this document for a while to define data science. I certainly have used it to argue to the CEO of the New York Times why we should have a data science team. People like this document. They don't often talk about the left end, which is the danger zone, but the danger zone is real. If you torture the data enough, it will confess to anything. And you don't need a team that just tells you what you want to hear. You want a team that's going to tell you something that has some science behind it, which is part of the science. By the way, hacking skills doesn't mean breaking into things. It means the original hacking definition from the 50s, a creative solution to a technological computer, a problem. Or said otherwise, making the computer do what you want it to do, rather than what it wants to do to you. Good. So that's the way we think about the data science team at the New York Times. It's a team that develops and deploys machine learning solutions to newsroom and business problems. Develop means that we need to understand machine learning well enough that we can go a little bit beyond scikit-learn. Deploy means we ship to prod. That is, we're not trying to generate insights. We're trying to write working APIs, working GUIs, working Slack bots, things that we can integrate into process. So now I've told you a little bit how we think about data science at the New York Times. Let me tell you where that sits within the New York Times. In order to explain to you where this sits in the New York Times, I need to show you the org chart of the New York Times. Here's the org chart of the New York Times. Oh, sorry. First, I'm going to show you. Sorry, I'm not using Keynote, so I don't actually know what's coming next. So this is a birthday picture of the New York Times from the day it was born in 1851. And many people think about the New York Times like this as a newspaper, which we still make newspapers. This is the org chart of the New York Times. So church are the people who possess and defend the craft of journalism. State is everything else. And I want to make clear that I am on state. So you may have experienced the New York Times product. You may have seen awesome infographics, awesome data journalism. Those people are awesome. Those are not my people. My people are on the state side. And so I'm going to show you some examples of things that we do to try to make the New York Times, among other things, economically strong. There's a very particular type of freedom that you have when you are profitable. And we would like to help the New York Times maintain that type of editorial freedom. So I'm on State, and in particular, I'm in a group called Data. Now, you may wonder, where does the New York Times have data? Well, the New York Times has a website. The New York Times created a website on January 22nd of 1996. And the consequence of having a website is you have the opportunity to learn from your readers or your customers at scale. The New York Times does so. We no longer print all of these data on our website, which I think is a good idea. I don't know why we were ever being this granular with our publicly exposed information, but yeah, you get a lot of people looking at our website all the time, and then you get equally number of people using the mobile app. So we get an abundant amount of data from people interacting with the website, and each one of those transactions liberates some data about who people are and what they're interested in. This is not violating NDA. You can open up the developer tools of Chrome and see it for yourself. So we have abundant data. We're not the only company that has abundant data. If you've ever wondered, why does Google know how many people are at Blue Bottle Coffee in Brooklyn every hour of every day? It's not because they use a survey. It's because they are spying on you all the time. This is well known. It's well known that you can actually put these data to work to learn a lot. This is a quote, social activities generate large quantities of potentially valuable data. The data were not generated for the purpose of learning. However, the potential for learning is great. That sounds like a very modern quote, but it's actually from Bell Labs in 1993. So we build on a tradition that some companies have been working on for a long time. If you look a lot of the ancient documents from Bell Labs, you will see a lot of things that sound a lot like modern data science, but that's another talk. This is a paper called Greater and Lesser Statistics by John Chambers. Just so I know my audience, how many people have ever heard of John Chambers? John wrote S. How many people have heard of S? S was the commercial thing that begat R. How many people have heard of R? Good. Okay, so John Chambers. Anyways, they were ahead of the game at Bell Labs. New York Times takes this challenge seriously, the challenge of learning from data. If you want to read more about it, we wrote a report about it called the Innovation Report, which was promptly leaked to BuzzFeed, so you can now read all of it. One of the things it talks about is the challenge of being an incumbent in the presence of so many disruptors and not allowing yourself to get complacent because you will get disrupted. Part of that disruption is the change in economic business model of journalism. For centuries, the craft of journalism was tied to the business model of newspapering, and the newspapering was tied to advertising. The New York Times, like every publisher, has undergone a sea change in the last decade, in which, among other things, we've transitioned from an ad-based model to a subscriber-based model, which, to my mind, aligns incentives quite a bit. Okay, so another recommendation of the Innovation Report was that it might be useful to have data inform things on both the church and state side, and that is what we have aimed to do. Now let me give you some examples of how we've done that. I've told you that we're on state but not church, which means we're doing data science and doing machine learning but not data journalism and not infographics. Let me give you some examples of how we think about it. The words that I use when I talk to my business partners, the product owners, the editors, are I talk about some of these projects as being to describe the world, some to make predictions, and some to make prescriptions. Predictions means I'm going to tell you what's going to happen in the absence of any intervention. I'm going to tell you the outcome in the absence of any treatment. Prescription means I'm going to tell you which treatment you should invoke in order to get that outcome. And depending on where you are in your relationship with a project or a marketing campaign, you might actually want different types of modeling. You might want different types of partnership. Now, internally to my groups, I tell people, shh, don't tell anybody, but these are really unsupervised learning, supervised learning, and reinforcement learning. So among my technological group, that sort of guides what literatures we build on, but I don't want to use these words when I'm talking to my business partners or my product owners. I also use these words because these are the words business people already use. For example, here's this chart from Gartner. If you've never heard of Gartner, it's a company that you pay to tell you what's happening. And they made this thing in 2012 saying, if you really want something valuable, aim for prescriptive analytics rather than descriptive analytics. That takes more work, though, because it means you are willing to sit down and think about what is it that you think is relevant, what is it that you really want people to do, and what is it that you are willing to do in order to get that outcome. So it is more difficult because it requires you and your business partners to be able to really think through much more of the problem. It also requires you actually do some interventions, and not every company is willing to let data scientists, do experimental design and set up an A/B test or something like that. Descriptive problems. An example of a descriptive problem is taking the corpus of the New York Times article and breaking it into different topics. This is how we used to do our recommendation engine. We would, it used to be a little widget on the right-hand side saying recommended for you. We could do that by saying that an article like this about the Frick Museum is partly about politics, but partly about art. That's useful because then you could build a model of how people interact with all of the text. So the text is a bag of words. People are either reacting to or not reacting to it, and you can build one consensus model. We did this building on work by my friend and colleague Dave Bly, and if you know anything about LDA, this is like an LDA but worse. And in fact, the loss function looks like a combination of the LDA loss function and the Netflix loss function put together. I was able to do this because I was already doing this kind of work for making sense of large electronic health records. We did the same thing with colleagues at Columbia Medical School, which I bring up as an example of why, if you're starting a data science team, it can be useful to work with people from academia, particularly people who already are trying to apply machine learning to a substantive domain. Another example of why we might want to build a descriptive tool is this fun tool called ReaderScope. ReaderScope gives you a way of understanding who is reading what where. That is, we take the topics, which is the what, information about people and who they are, whether they're business decision makers or other things that marketers are interested in, and where they are, because you might want to know what topics are over-indexed in LA or Houston or among the C-suite or business decision makers. So we can do that. Let's give some examples of prediction problems. Prediction problems, again, are ones where you want to predict what's going to happen in the absence of treatment. As an example, any digital subscription service should have some model that predicts which people are at risk of canceling their subscription. This is called a churn model. So this is not breaking NDA. Actually, this chart is from the innovation report. But we're interested in things that are not only predictive, but interpretable. So something we've talked a lot about quite a bit in this conference, in fact, there's a competing talk happening right now on that subject, is how do you build models that are either interpretable because the model is simple, or explainable because after you've built the model, you can try to explain how it works. We have that challenge. Again, that's a challenge that academics face as well. In my own personal experience, you can build a model that predicts which genes are going to go up and genes are going to go down. You can bring it to your yeast friend, and your yeast friend will say, I don't really care. I want to know what are the sequence elements that control those genes. So that is a challenge that people in machine learning applied to academic problems have some experience with. It's also something that has been known from consultants. Great consultants like Leo Breiman. Leo Breiman is well known as an academic statistician, but part of the way he got to be Leo Breiman was he spent about 2 decades just walking the earth and doing crazy things like developing random forests or developing CART, and really learning how people put data to work in the real world. He wrote this great article a long time ago about how what we do when we make sense of the world through data is a balance of prediction and interpretability. We also predict how many copies of the newspaper will be needed at every store that sells single copies. There's not much I can tell you about the guts of that, except to tell you that although that may not sound as exciting as cat face science, where you tell if a picture has a cat face in it, I can scientifically prove that I'm saving multiple data scientists' salaries by using science rather than using the technique they were using before. We also do predictive problems that are helpful to journalists. An example is Hiroko Tabuchi, who's a journalist, was interested in airbag fatalities in car crashes. She had this huge government database in Excel, which was sad. We downloaded it, made it Pythonic and useful, insane, and then we built a little model that told her, here are the fatalities that we think you should go look at. She then wanted to know how it worked, so we built an interpretable model that said, well, if it has the phrase suddenly deployed or burned, you're probably going to find this interesting. And that led to a series of articles and then to eventually to a recall of this particular airbag. We also do some things where we don't care about interpretability at all. So for example, we have this before and after data set of editors subtly changing the color balance in a photo because when it comes out of the journalist's camera, it may not be ready to become ink. So we use some deep learning to give editors a warm start so that rather than starting with the original image, we can say, here's an image using deep learning where we predict this is how you would like to rebalance the colors in that image. Another prediction problem is predicting what people will feel when they read the article. We did this as a summer intern project where we did some crowdsourcing, showed people articles, asked them what feelings they felt, and we said at the end of the summer, okay, that was fun, goodbye, intern. And then my friend from advertising heard about it, and he said, sweet, I can monetize that, and he did. So this is now something you can buy. So we call it Project Feels internally. Externally, it's called perspective targeting. But the idea is, let's say that you're a marketer, you may not care if your brand appears in the travel section or the sports section, but you may want your brand to appear next to an article that makes people feel inspired or hopeful. This has been a huge success. We've talked about it publicly. An example of crowdsourcing is shown here. People actually write back to you and say, hey, have you thought about this other thing that you might want to try, which is something I never got when I was working on yeast. And you get to do some science about the way people feel, just to do some sanity checking. And it's been great. So in 2018, more and more people used it. I can't show you the data for 2019 yet, but again, it is saving multiple data scientist salaries, or even teams of data scientists by doing this. Good. Prescriptive, though. I'm going to save the best for last. Prescriptive models are those where you actually help people with decision support. It takes more work because you're not just predicting what's going to happen in the absence of intervention. You're guiding people into what intervention they might want to do. As one example, in 2014 in the innovation report, we said we are not keeping up at the art and science of getting our journalism to readers. So the New York Times created a team called the Audience Development Team that was interested in thinking about our relationship with a story after you hit pub. So in the print world, when you hit pub, that's publish, sorry. When you hit publish, that's the end of your relationship with the story. That's why we use the phrase stop the presses. In a digital world, that's where your relationship with the story starts. You hit pub, and then you think, well, should I be posting this on Facebook, the sports Facebook page, Twitter, the sub-account for arts? How should I be making sure that people actually see this thing and that our stuff is read, to quote the editor-in-chief? So we built out a predictive model for predicting engagement as a function of how you promoted it. We were all very happy about it. And then we realized that the editors will not use Python. We cannot get editors to fire up Python. In fact, based on prior failures, we knew that editors wouldn't even open up a new web app. Even if it was in our best, most beautiful Flask app, we couldn't get our editors to open up yet another web app. However, around that time, editors were falling in love with Slack. How many people here know Slack? Good. So Slack is like IRC. How many people here know IRC? Nobody. I'm old. OK, so there used to be this thing called IRC. It was a chat program. Slack is that, except with a hot interface, and you can program it. So you can easily build a Slack bot. So we built this Slack bot called Blossom. So we had to think like product people now. What should we call it? We shouldn't call it THX XJBoost 9001. We should call it Blossom, because like when you pour water on a flower, it blossoms. And Colin, the software engineer, made himself a little icon of a teddy bear, which is hugely fun inside our group because Colin is nothing like a teddy bear. But that was useful for getting editors and to actually want to use this bot, which you can ask it, what should I be posting on Facebook right now? And it will give you advice, which you can turn down if you wish. Or you can set Blossom to interrupt you and say, seriously, you should be publishing this right now. This is data informed rather than data driven. It is not run in the open loop. It is done in a way that advises editors, and then they can think through whether they want to do that. A different type of prescriptive problem that you have at a news organization is recommendation itself. So a lot of the literature on recommendation is about matrix completion or other things where you're essentially doing regression. We don't treat it that way. We treat it as a reinforcement learning problem. So if you've looked at the New York Times lately and you've seen things that are in the Smarter Living widget or the election widget from the state's election in fall of 2018, or on the right-hand side where there's editors' picks, these things are personalized for you using a reinforcement learning technique. Now you can get this as well in the app. I encourage you to check out the mobile app. It has a tab called For You. That stuff is for you. We do this using reinforcement learning. Reinforcement learning is sort of the less discussed third half of machine learning, but it's gotten quite a bit of attention in the last 4 years. In 2015, Google DeepMind showed that you could play Atari games. Atari is a video game that we used to have. Really well using reinforcement learning techniques, and more recently it's done a pretty good job beating human beings at Go. It is also not just being done by Google, but normal mortal companies like Stitch Fix or the New York Times. Here's an example of a blog post from November of 2018 by Stitch Fix about how they personalize using Contextual Bandits. Actually, there was a talk yesterday from Netflix also about Contextual Bandits. Why do we call it bandits? Well, we call it bandits from the phrase one-armed bandit, which is another word for slot machine. The abstraction is you show up in Las Vegas, you have a bag of quarters, you're in the airport, which if you've ever been there is a terrible place, really noisy, and you want to make as much money as possible. You do not want to maximize likelihood or learn exactly how bad the bad arms are. You want to make as much money as possible. So that abstraction of doing optimization by exploring and exploiting is the bandit problem. So we do that at the New York Times. It builds on ideas like a randomized controlled trial that you might have heard of. It was hot in 1925. It changes the idea of a randomized controlled trial. Instead of doing everything with equiprobability and then going with the winner forever, you gradually do the winner more and more. This is done by a number of techniques. Actually, yesterday's speaker from Netflix did the same thing, talked about epsilon greedy, UCB, upper confidence bound, and Thompson sampling as examples. Thompson sampling is my favorite because it's old. But it's also been useful for inspiring some academic research that I've done. So it has inspired a variational approach, not unlike the variational approach I mentioned earlier. and it's inspired a mathematically rigorous form of genetic algorithm in which you go back and look at what worked, slightly mutate it, and upweight the things that work. So what have we learned? What we've learned in data science is that you need people, ideas, and things in that order. This is a quote from the United States Air Force. We like to think about things, you know, like AI and A/B testing, right? And those are useful, but you need to do them in the right order. You need to get your fundamentals correct before you start doing fancy AI. We like to think about ideas, like exploring and then testing and then optimizing, and I've talked about how those ideas relate to each other. Those ideas are important. You need to go back and learn how things work when you change the laws of physics. When you're a machine learning engineer, you need to think about primitive engineering ideas like speed, scale, and cost. Absolutely important ideas. But ultimately, it's the people that matter. We need to think about things like explainability, and I'm not the only person to point this out. This graph actually was showed yesterday about DARPA and how DARPA is funding a lot of work to try to take black box machine learning models and make them explainable. The New York Times takes this seriously, and I'm not violating NDA to tell you this. The New York Times is on record as saying they will be investing a lot in AI. The ideas and the things, though, are not as important as the people. So we've built up a data science team over the last 10 years by drawing on people from a variety of backgrounds, mostly natural scientists. I encourage you to do the same. I will note in passing that at least 4 of these people, and also one other guy who we hired, but then he went to Google, were hired from the Insight Data Science Fellows program, which is at the booth out front. Genevieve and her people are nice to work with. So if you're trying to build up a data science team, I encourage you to talk to them. If you're thinking about starting a data science team, I encourage you to think about working with academics who have a lot of experience partnering with other people. And if you're looking for a data science job in New York City, we are hiring. And with that, I look forward to taking your questions.
And you show us your team members. They have some math background, physical background, etc. But I didn't find people have computer science or computer engineering background, right? So I just curious whether you think people with physics, mathematics background better fit this job than computer science background.
No, I mean I don't discriminate about PhD or academic background. It's just the way the chips have fallen. I do think it's useful to have people who have experience working with somebody who's complementary to you. So for example, people who have done biophysics, that's a difficult job because you're often working with a real biologist who thinks that real science doesn't involve calculus. So you have to really work with, it's true, that's my experience. So, don't get in the way of real science. So, in my experience. So, those people just, they have experience working with people from a complementary domain, right? And complementary review is the opposite of peer review, right? Where you do something that you and other people just like you can understand. So I'm thrilled to hire people from statistics or computer science, neither of which is as yet represented.
Thank you.
Sure.
Hey, so I have a question about investigative journalism side. So I went to the Brown Institute by Columbia. I attended a whole day, and I was amazed to hear how much programming journalists, students at the time, probably journalists now, were learning. So all about going through databases and whatnot. I'm curious, does your data science team support journalists by doing the data science for them, or do you work with journalists who are doing data science and complement it?
Almost not at all. So I showed one example of what is called computer-assisted reporting. If you'd like to know more about the history of this field, there is an organization called NICAR. It is old. The phrase data journalism is sort of new, but people have been doing this for a long time, originally under the name precision journalism. We rarely help the journalists. The thing is, those people have deadlines, and our projects tend to take a long time. We tend not to be so useful to people when they have a story that's coming out next week. So most of the stuff that I do is either on the business side or with editors helping with process efficiency rather than with journalists. I mean, I know journalists, talk to them, I'm happy to be useful to them, but it's mostly outside the scope of my group.
Hi, thank you. You talked about sort of explainability and understanding what goes behind the models to make these predictions, and I think you talked about it largely from helping the internal client user. But do you see, or what is your stance in exposing those things to the end, reader? Of the journal article, do you think there's benefit in saying, hey, we pitch this to you because the following criteria? Do you think that that would be a positive or negative experience for the user? And do you think that that's something the New York Times or other organizations are going to start doing as we go forward?
It's a good question. I mean, we could do that. Netflix used to do this by saying, recommended for you because you accidentally clicked on this Tom Hanks movie once, and now you're suffering through Tom Hanks forever. No offense, Tom Hanks. We could do that. It hasn't been top of the priority queue. But interpretability matters a lot when you're working with somebody and you're trying to say to them, you should change your marketing campaign, or you should create a new product because of this.
First of all, as a biophysicist, thanks for standing up for biophysicists.
Yeah, that's my background. Like you can look at my literature. I got a bunch of biophysics papers.
Yes, I think I was at a conference that you were in anyhow. But so the thing I wanted to ask is that New York Times does a lot of like predictive sort of like, their polls that they take, the predictions for election results, stuff like that. Do they ever use the data scientists that work at New York Times for that sort of stuff?
I mean, I've talked to the team. That team is the Upshot. They've got some really good people. I mean, Amanda Cox, Josh Katz. Those people know what they're doing. So I've talked to them a little bit. They don't really need me. And also, it's not clear that it's not really a machine learning problem because the thing that they're predicting is a type of democracy that basically only happens once every 4 years. It is not a kind of machine learning problem where you can really put the kind of things that I'm interested in to work. So, like all other journalists, like I'm happy to help them, but the way that they're approaching the problem, and Amanda is still, she's pro surveys. So Amanda Cox is the editor in charge of the Upshot. There's not so much machine learning I can help them with.
Because I mean, there's like the stuff that Nate Silver does to like sort of basically like look at like how closely things are related. So look at like correlated shock basically across the system, and so try to make modeling based on that.
Sure. So Nate, you may know, was at the New York Times, and before 2013, exactly. that was his bag before they created the Upshot. Exactly. So the Upshot was in part created because of Nate's withdrawal. Okay, yeah. So Upshot and Nate are doing very similar stuff. Nate, I think, does a good job, as does the Upshot, combining it with traditional economics. Right, so traditional economics is a field where you try to infer causality by making modeling assumptions, right? And again, that's a field where, if you look at Judea Pearl's book, The Book of Why, I mean, it's clear that like sometimes you don't have causality by just like applying the big data to it. You have to make some sort of modeling assumptions. Right. So yes, that is a style of modeling, but it's not what I'm particularly good at. Okay. So again, I'm happy to support those people, and I have talked to them, but the style of modeling they do is, I would say, different.
So you leave that to the Upshot team?
With pleasure.
Yeah.
Yeah, and also, I don't want to be responsible for that on November 9, so.
Thank you.
Sure.
This will be our last question.
Okay.
Yeah, come on up. Hi. So I was listening to you earlier talking about like Netflix, like how it recommends different movies, right?
Yep.
So I was thinking like, do you do similar things when people like read the paper online? Like they read a story and like, here's, because you read this story, here are these kind of stories recommended for you, or these kind of articles that you can read.
Right. So when you say similar to Netflix, you could mean the statistical challenge, the engineering challenge, or the product-facing.
The statistical challenge, like the recommender system.
Our problem is much less hard, because they're talking about a large number of movies to choose from, and their action space is very large. As the speaker made clear yesterday, the personalization includes the layout this way, what time they email you. We're talking about some very carefully curated pools of content that are served in some very carefully curated sets of pixels. So we have a much smaller problem in some way, although we have fewer monthly active users. But I would say that it's similar in the sense that we're all using reinforcement learning or sequential decisions theory. She changed her title to try to explore and exploit at the same time. But it's different in that I think what they're doing is much harder. That said, we have 10 data scientists. They have more.
Okay, thanks.